Hi, welcome to the Unit R Day 1 Notes. This is for college algebra. Welcome, friends. Let's jump in. Starting off, we're going to talk about sets of numbers. Sets of numbers, we have different types or sets of numbers. If you go back, we're going to fill this set of notes section out differently. We're not actually going to go in order this way, so bear with me. I want you to think about how we learned numbers going back to maybe when you were a child. If you think about when you were growing up, you first learned the number 1. And then after 1, you learned the number 2 and the number 3. And we call these the natural numbers. And the natural numbers they're observable in nature. You can see 1 of something, 2, 3. So that's where natural numbers actually come from. Natural numbers, they occur in nature. So here, we're going to write an example of what the natural numbers are. I'm going to use something called set notation. Set comes from here. And the way that we use set notation, we use this curly brace, and then we do 1, 2, 3, and now I could continue saying the natural numbers forever because they keep going towards infinity. 4, 5, 6, 7, 8. I don't have time for that. You don't have time for that. So we'll leave it off as 1, 2, 3, and then we put this ellipses to know that they go on forever. The next part, and then over here off to the side, we have a symbol. We have a cool mathematical symbol that goes with the natural numbers, and it is a n. Now, it's actually a script n. It's really hard for me to make a script n, so you'll see me often do something like this to show that it's actually a script n instead. I just put 2 additional lines, kind of making it almost look somewhat three-dimensional. It's a little bit hard to create and write. Capital N serves just fine. The next set that the next additional number that you learned, we actually taught you the idea when you were young. We taught you the idea of having nothing. You were probably unhappy about this because you wanted something and you had nothing. That's generally how it works. But the idea of having nothing is represented with the number 0. We call those whole numbers. So again, this starts at 0. So I'm going to use set notation. Set is this curly brace. 0, 1, 2, 3, and so on. Whole numbers are represented with a W. Same idea, where it uses the brace script, the script notation for this. The W idea from whole, natural numbers is the letter N. It gets a little bit different from here. All right. After you learned whole numbers successfully, you were then taught the idea of what an integer is. An integer is when you have less of nothing. And this idea we incorporated into negative numbers. So if you think about negative numbers, if I do the set, if I start at the last negative number, well, there's no last negative number. So we're going to put the ellipses here to show that the smallest negative number is, well, towards negative infinity. And then I'm going to go ahead and put negative 2, negative 1, 0, 1, 2, and so on. Again, this is set notation. Alright, so integers. You think, oh, that's capital I got this. It's not. So integers, the word actually comes from, the symbol actually comes from the German word for integers, which is Zilif. So integers is a Z. Again, this is something that was incorporated by the Germans. It's their word for integers, so we use the letter script Z. Next is irrational numbers, rational numbers, and real numbers. This is where things get a little bit dicey depending on how you learned. Irrational numbers are real numbers whose decimals don't repeat. So we kind of taught you rational numbers and irrational numbers at the same time. Irrational numbers, an example of that would be like pi or square root of 2. Those decimals, if you think about the approximation of those, they go on forever and they don't repeat. So an irrational number is a real number with a non-repeating decimal. With a non-repeating decimal. Notation for that, we either use an I for irrational, or you might see an H used as well. Again, I comes from English, H, those Germans. The rational numbers. This is a real number with lowercase n. A real number with either a terminating or repeating decimal. So if you think about this, when you learned about any fractions, that's the idea with rational number. A rational number is essentially a number that can be represented as a fraction. So the way that we usually write that is we would write an integer divided by another integer. So it can be represented by an integer, which I'm going to use a symbol for it. So an integer divided by another integer. So that could be represented as rational. Rational numbers, the word for it, again, comes from German. And so you can imagine it doesn't start with R, it actually starts with a Q. So there's your Q. And then this brings us to the very top where we talk about real numbers. And the real numbers are the set of all rational and irrational numbers. And you probably have seen the symbol for this. This is where that R comes into play. And out of all the symbols, this is probably the one I'm the most confident making. So that's a capital R with another line and a bar coming down. Let's go ahead and fill out this chart here. So the set of numbers. So this chart here gives us, up here at the very top, we have the real numbers. So the reals are contained, or sorry, the real numbers contain the rational. So the rational is going to go on this side. And the irrational is over here. I'm going to go ahead and turn this sideways. Sorry, that's a little bit irrational of me to do. I make a lot of puns. You'll have to bear with me on that. And then within the rationals, we have the integers. Within the integers, we have the whole numbers. And then within the whole numbers, we have the natural numbers. Now, one thing that you'll note here is that the naturals are contained within the whole numbers, all of the naturals, but all of the whole numbers are not contained within the naturals. An example of that would be the number 0. The number 0 is a whole number, but it's not a natural number. So you can have things that are kind of overlying or gaps if they're created this way in this chart, but they don't extend beyond. For example, the way that we define a rational number is an integer divided by an integer, but the way that we define an irrational is not using these concepts over here. So you have to be careful. The next part, what we have in our notes, has to do with set notation. This chart kind of moved the box down, but set notation, there's 3 symbols that we're going to focus on in this course. The first one is this symbol right here, which looks like a C, capital C, but it's kind of elongated, so it's longer than normal. This may be backwards. Longer than normal. So this elongated C, we say, is a proper subset. Now, if something is proper, then essentially what it means is that it belongs. And we say a subset, so that means it's within. So the naturals are a proper subset of the whole numbers. All of the naturals exist within the whole numbers. The next thing that we're talking about is an element. An element symbol looks like a E. This E looks a little bit kind of rounded on the edge, and this is an element of. We talk about numbers being an element of the sets. For example, 1 is an element of the natural numbers. Similarly, we could say something is not an element. So if I put a slash through it, just like with most things in mathematics, we put a slash through the symbol, it means it's not. So this is not an element of. For set notation, we have proper subset. We talked about that earlier. This is a subset that is contained entirely or wholly in another set. Empty or null set, that is a set that has no elements. The symbol for an empty or null set is usually this, or you can have an open and then immediately closing curly braces. Now these are called braces. You'll hear me call these braces and then I call something else brackets. Make sure that you know the difference and make sure that you can communicate the difference as well. These are braces. So this is for empty or null set. And this is the set with no elements. Example of a set with no elements, the number of students that I had in my classroom physically in, let's say July, and I'm not teaching summer school. So that's an empty set. There are no students in that classroom. Next video, we'll start with example 1. Have a great day.